Hello and welcome back. So now we're going to talk about molality or molal concentration. And molal concentration, if you're used to molarity, it sounds like we're saying something wrong, but we're not. So molality actually is typically given the symbol little m. And molality is defined as the chemical amount of solute, or if you like, the number of moles of solute, divided by the mass of the solvent in kilograms. So it is kind of a difficult one to remember here, but there you go. It's the mass of the solvent, not the whole solution. So in terms of units, so the units I think are fairly easy to understand. We're going to have moles for the units on the top, and we're going to have kilograms for the units on the bottom. So that would be moles per kilogram. You could write moles kilogram to the -1, and because we decide that's kind of a mouthful, we can normally just abbreviate that as a lowercase m. But remember, a little m and a big M stand for two different things. So a little m is molal concentration, and a big M is molar concentration. So be very careful. In the first semester, I always get down on my knees and I beg you, please, please, please write it properly, right? Please write a capital M for molal concentration, because when we get to the second semester, we introduce a brand new concentration term, molal. So a little bit different. So since we haven't played with this before, let's do a calculation and figure out the concentration in molal concentration units. All right, so let's have a go at a problem. So maybe we dissolve 50 grams of a solute, okay, with a molar mass of 25 grams per mole. So that curly M, right, is how I'm going to represent molar mass. And we dissolve it in, say, 100 grams of solvent, whatever it may be. Maybe it's going to be water. And the total volume happens to be, say, maybe 125 milliliters. And from that, we can calculate the molar concentration and the molal concentration. So it turns out the molal concentration, as far as I know, doesn't have an abbreviation, but the molar concentration is those square brackets. So how do we do that? So molar concentration is number of moles per liter. So we've got 50 grams and 25 grams per mole, so we can convert. So 50 grams, and we've got a molar mass of 25 grams per mole. So we can see that that is 2 moles of our solute. And the molar concentration is moles per liter. So the molar concentration would be 2 moles divided by the volume in liters. So 125 milliliters is 0.125 liters. And if we do that division on our calculator will say 16, but of course, significant figures, it's 16.0, and the units are moles per liter, or capital M. Now, if we wanted to instead calculate the molal concentration, we would do almost exactly the same thing, but we would take not our number of liters of solution, we would take our number of kilograms of solvent. So this is our solvent. And if you remember, there's 1,000 grams in a kilogram, thereby 100 grams must be 1/10 of a kilogram, so 0.1000 of a kilogram. Actually, dividing by 0.1 is like multiplying by 10, so I can see that is going to be 20 moles per kilogram, or molal. So you can see it's fairly close in number. It turns out molarity and molality will often be very similar, but in magnitude, particularly for dilute solutions, for concentrated, you can see here they're a little bit off, but that gives you a way to calculate those two different concentrations. Which one is better? Well, they're actually both pretty good. There are some real advantages to using the first one. So this makes it very easy to figure out moles by just measuring out volumes in liters. The second one, you really have to weigh out the solutions, I suppose, to have a good shot at calculating that. But the tremendous advantage of molal concentration is what happens as you change the temperature. The molal concentration is completely unaffected. So the weights and the number of moles, right, they don't change with temperature. However, if we heated up this solution and there's a volume expanded, because we would be dividing by a larger volume, we would be lowering our concentration. It would be more dilute as the temperature rose, and conversely, as we cooled it down and it shrank in volume, it would be more concentrated, whereas molality would be completely unaffected. So that's one major advantage to molal versus molar.